Section 11.1.21, a survey asked how many tattoos do you currently have on your body? Of the 1,1252 males surveyed, 174 responded that they had at least one tattoo. Of the 1,337 females surveyed, 128 responded that they had at least one tattoo. We want to construct a 90% confidence interval to judge whether the proportion of males have at least one tattoo differs significantly from the proportion of females that have at least one tattoo. And then we're going to interpret the interval. Well, first we're going to let P1 represent the population proportion of males with tattoos. We're going to let P2 represent the population proportion of females with tattoos. To construct a confidence interval for two population proportions, P1 and P2, the requirements below must be satisfied. If the samples are obtained independently, we're going to use the simple random sampling. We're going to take these values and then make that sure that's greater than or equal to 10 for males, and then for females, make sure you multiply those values and make sure it's greater than or equal to 10. And if sample sizes are no more than 5% of the population size, then the bounds for a 1 minus alpha times 100% confidence interval for the difference between two population proportions, P1 minus P2, are given by the following formulas. Here is the lower bound, and there is the upper bound. Where N1 is the sample size for males, P subscript 1 hat is the point estimate, and X subscript 1 is the number of males. And likewise, for the second is going to be all the corresponding values for females. And Z alpha divided by 2 is the critical Z value. Now, once we find the confidence interval, if the confidence interval does not contain 0, then we're going to conclude that there is sufficient evidence of a significant difference between the proportions. Otherwise, there is insufficient evidence of a significant difference between the proportions. Okay, so the first thing we want to do is we want to be able to then determine, okay, what are the values for x1, n1, and find the point estimate. Okay, so if we take a look up here, we will see that x1 represents 174 males that responded to have at least one tattoo out of 1252. So we see there's x1, there's n1, and we want to find the point estimate. The point estimate for 1 is taking x1 divided by n1, which is 174 divided by 1252. Now when you divide this, if you're not going to leave them as fractions, then we're going to leave them as decimals. My recommendation is round it to 5 decimal places so you're safe there. Okay, now we're going to find the point estimate for females. So let's go ahead and do that. So for here, to find the point estimate for females, okay, what do we know? Well, if we look at our question, okay, we know that there's 128 females that responded that they had at least one tattoo, so that's x2. And we can see that the total females surveyed was 1,337, which gives us 128 over 1,337. And rounding that to 5 decimal places gives us 0.09574. Okay, now the next thing we want to do is we want to be able to determine if these are going to be greater than or equal to 10 for both the male and female. So let's go ahead and write that out here. Okay, so we want to make sure that this works. So we're going to take the sample size for N1, which is 1252, multiply it by the point estimate of 0.13898 times 1 minus 0.13898. When we multiply that all out, we get 149.84, which is greater than or equal to 10. And likewise over here, we're going to take the sample size, and let me go ahead and rewrite this here so we have this in a nice way here. We have the sample size of 1337 times 0.09574 times 1 minus 0.09574. We want to make sure that's greater than or equal to 10. And so we get 116.03, which is greater than or equal to 10. Okay, now in addition to what we have in the formula, we need to find the critical value. Okay, so the next step is to find the critical value. Now, we need to look at the fact of what alpha represents. So if we want to find the critical value here, okay, we're looking for Z alpha divided by 2. Now let's come back up here and we're going to construct a 90% confidence interval. So that means alpha is going to equal 1 minus 0.90, which gives us 0.10. Then we're going to take alpha and divide it by 2. Well, that's going to be equal to 0.10 divided by 2, which is equal to 0.05. So that means over here in this critical value here, the area to the right is 0.05 and the area to the left is 0.95. Okay, so we can use the function on our calculator, Inv Norm. So let's go ahead and do that. So we're going to go ahead and select second distribution. We're going to go to Inv Norm. Okay, so we want the area to the left of that critical value, so it's 0.95. We also know that the mean is 0 and the standard deviation is 1. Oops. Okay, and then we're going to go down here to paste and then select enter, and then we get 1.6448,53626. So there is our answer. Now we need to round that to 3 decimal places, which gives us 1.645 for the critical value. Okay, now for step number 3, okay, we want to be able to find the lower bound by filling in the information. Okay, so if you notice here, we're going to take the value of what we found to be the point estimate for 1, which is 0.13898. And then we're subtracting the point estimate for females, which is 0.09574. Okay, and then we're taking our critical value minus 1.645, and then it's going to equal the square root of 0.13898, which is the point estimate for population 1, and then we're going to multiply it by 1 minus 0.13898 divided by the sample size for males, which is 1252. And then over here, we're going to be plus the point estimate for females, which is 0.09574, times 1 minus the point estimate for females, divided by the sample size. Okay, so let's go ahead and put this into our calculator. Okay, so what we're going to do is we're going to go in order of operations. We're going to take first the square root, so the second square root, and then what we're going to do is we're going to contain this in parentheses and then this in parentheses, add them together, and then take the square. So we have the square root of parentheses, and then in the numerator we have parentheses 0.13898 times 1 minus 0.13898, and then we're going to divide that by the sample size of 1252, close the parentheses. And then we're going to have the addition sign, so that's plus, and then we have parentheses, and then another parenthesis, which is 0.09574, and that's times 1 minus 0.09574, and then we're going to divide that by the sample size, 1337, parentheses, and then close the parentheses, and then we have our value there. So that's what we get for this part. Now we're going to multiply it by minus 1.645. So we're going to take times and then negative 1.645. Okay, so now we've multiplied it by negative 1.645. Now we're going to add that to this. So we're going to say add, and then parentheses, we got 1.13898 minus 0.09574, and then close the parentheses. And then therefore, there is our value. And that's our value for our lower bound. Okay, so now we know that our lower bound is going to equal this amount here. Okay, but we want to round it to 3 decimal places, so we're going to round it to 0.022. Okay, so now we want to find the upper bound. Okay, so the upper bound is basically using the same numbers, the same values. Okay, the only thing that's different here is I'm copying that, is that now we need to add what is to the right. So we need to add this amount. Okay, so basically we can either come up to this value up here, again, which is 0.126621895. That's what we got when we found the square root of this number. So on your calculator, you can come all the way up here and hit enter. And now we have that number. And then we can multiply it by a positive 1.645. So we're going to multiply that by positive 1.645. Okay, so now we got this number times this, and now we're going to add this order of operations. So we're going to put plus, and then we're going to take 0.13898 minus 0.09574. Okay. And now we're going to hit enter. And now we have our upper bound. So let's go ahead and copy that value from our calculator here. Okay, so here's our value. We want to round that to 3 decimal places. So if we round that to 3 decimal places, then we get 0.064. Okay, so now we can determine what is our interval, our confidence interval. So our confidence interval is going to have our lower bound, comma, upper bound. Okay, and so what does that mean? We have a lower bound of 0.022, and we have an upper bound of 0.064. Now the question is, going back to the very beginning, we want to know, okay, now, if the confidence interval does not contain 0, then conclude that there is sufficient evidence of a significant difference between the proportions. Otherwise, there is insufficient evidence of a significant difference between the proportions. So let's take a look here. Now, can we say that this interval contains 0? Well, if you look here, this 0 is not in this interval. So therefore, we're going to conclude that there is sufficient evidence of a significant difference between the proportions. So here is our conclusion. We can say that there is 90% confidence that the difference of the proportion is in the interval. We conclude that there is a significant difference in the proportion of males and females that have at least one tattoo.